All right, we are now officially going to start going through 5a. So this is 5a recursion relations. All right, let's give this a read. It says a recursion relation is an equation that allows you to calculate the next term in a sequence of numbers given you know the current term. So in general, as you can see here, we always begin by listing out our initial value. So we're v0, the initial value, starting value, first term. Then what you have after that is you have v of n plus 1. That is saying your next term is going to be, and then, as you can see here, we have this v of n, which is our current term. And you either multiply it, or add it, or perhaps you, or subtract it, or perhaps you do both. Perhaps you multiply and add or subtract it from something. And we'll be seeing this in action soon. How do we use our calculator to generate a sequence of terms? So using the CAS calculator to generate terms in a sequence. So the first thing you do in the calculator page, enter the initial value and press enter. That's very important. Then you type in whatever you've been given, plus 3 times 7 times 0.5 minus 100, whatever it is. And then you keep hitting enter each time to generate the next sequence. So continue pressing enter to continue generating the consecutive terms. And we'll be seeing that as we go through our examples here. So example 1, find the first 4 terms of the following recursion relations and state whether they represent linear or geometric growth / decay. Let's look at our first one here. So we're starting at 2, and our next term will be found by multiplying our current term by 3. That's how we read that off there. Initially, we should be able to figure out whether or not we're dealing with geometric or linear. It's clearly going to be geometric. The reason why we know, and let me just write this over here a bit. The reason why we know it's geometric is because we're multiplying. We can also say it's going to be geometric growth. The reason why we know it's going to be geometric growth is because we're multiplying a number here, this 3. This 3 is greater than 1. So whenever you're multiplying a number greater than 1, you know it's going to cause a growth. If I was to multiply this by 0.5, that would cause it to be a decrease, wouldn't it? Because it's less than 1, that would be halving each time. So that's how we kind of think about that. All right, let's now zoom in here and see how we go. We're going to have to write pretty small here and try to be as neat as possible. Let's first figure out our first term. My first term is going to be v of 0, which is 2. They've given that to us. Our second term. Our second term is going to be v of 1, which is going to be found by using our rule here. We're going to go 3 times v of 0. Now, v of 0 is 2, so it's just 3 times 2, which is going to be 6. I know it seems a bit laborious to write it like that, but I think it's helpful as we're just learning now. Then we want to find our third term. My third term will be v of 2. It's going to be 3 times v of 1, which is going to be 3 times, now this is where it's important. I'm going to start using my highlighter a bit. I'm going to take this 6, right? So that 6 now comes down here. Let me get my highlighter again, 6, because that is v of 1, right? V of 1 was 6, 3 times v of 1, I put that 6 there. And now 3 times 6 is 18. Then we go to our next one. This is our last one here, the fourth one. Oh, is that a bit too thick? Let's try another one. The fourth term. My fourth term is going to be v of 3 is equal to 3 times v of 2, which is going to be 3 times 18. And 3 times 18 is 54. Again, can you just take a note of this? That v of 2 is 18. That means I'm putting that 18 there to find my next number. So that's how it works. That's how you're doing this. Before we go on to the next one, can we just kind of appreciate something for a moment? And that is says we want to find the first 4 terms, and we've done that. First term, second term, third term, fourth term. But do you notice how the number of the term doesn't line up with our nth number? Do you see how my first term is v of 0, and my fourth term is v of 3? So it's not like lining up exactly there. So I just want you to take note of that. And we might leave us a little note here. Let's just write a little note for ourselves. Oh, where shall I write it? Let's just write it here. You can write it anywhere on the page. I'm going to write notice. Notice the position term That's what I'm referring to when I'm referring to these. I'm referring to those things. That's the position term. The position term and n number. When I'm saying n number, I'm referring to these things here. Rid of them. Whoops. Sorry, sometimes it does that. And n number are not the same. Are not the same. So just something to be aware of there. All right, are you ready for the next one? Hopefully you are. Let's go. Here we are. We're starting at 52. Our next term is going to be found by taking our current term and minusing it by 5. The fact that we're minusing a number here tells me that this is going to be linear. I'm not multiplying, I'm subtracting, therefore it is linear. I'm also subtracting, which means it's going down. It's going to be linear decay. Linear decay. My first one was geometric growth. This one is linear decay. How can we do this now? So let's come here. Let's give it a crack. I'm going to go. What is my first term? My first term is v of 0, which is 52. Then my second term is going to be v of 1, which is going to be 52 minus 5. Actually, before we do that, so can I go, before I write it like that, can I go v of 0 minus 5, which is the same as 52 minus 5. I just want to be very explicit as I'm doing it. So as you can see here, what I've done is I've said, well, v of 0 is 52. So v of 0 is 52. And therefore, 52 minus 5 is going to be 47. Then we can go to our third term. Our third term is going to be v of 2. Again, take note that this third and this v2 is a bit off, but that doesn't matter. They're one off. The position number and the n number are not the same. Just something to keep in mind as we wrote up here in our notice. I'm now going to take v of 1, and I'm going to minus 5 from it. What is v of 1? Well, remember, v of 1 was 47. So now I'm putting that into that position here. So now I'm going, all right, what's 47 minus 5? 47 minus 5 is going to be 42. Then I need to find my fourth term. My fourth term is going to be v of 3, which is going to be v of 2 minus 5, which is equal to, again, take note, that v of 2 is 42. So if that 42 goes there, so it's going to become 42 minus 5, which is going to be equal to, what's 42 minus 5? It's going to be 37. Cool. That's how it works, people. So just take note as we're going through that that's how it works. Shall we do one more? Let's do one more. All right. Here's C. As you can see, what it says is that we're starting at 10. Our next term is going to be found by this. So my current term multiplied by that plus 12. Isn't this odd? Now, we have to label this. This gets an interesting name. We call this, I'm going to write it out before I say it. Geometric. Oh, I'm running out of room. So what we call this is arithmetric, geometric. Now, we don't know whether or not it's going to be growth or decay yet. We're going to have to see that when we go through our sequence. But that's what we call it. It's arithmetic, geometric, and then it's either going to be growth or decay. Let's have a look now and see how this works. All right. So what I'm going to start at here is v of 0. My first term, whoops, sorry. My computer's just playing up a bit. Whoop, on computer. Pull it together. All right, my first term. My first term is v of 0, which is 10. My second term. My second term is v of 1 is equal to 0.5 times v of 0 plus 12. All right, now take note that v of 0 is 10. So that means I put a 10 into that spot right there. So what I'm going to end up with is 0.5 times 10 plus 12. You can put that in the calculator. You go 0.5 times 10 plus 12. It's going to be 17. Then you need to find the third term. My third term is going to be v of 2. It's going to be 0.5 times v of 1 plus 12. What's v of 1? Well, v of 1 is going to be, v of 1 was 17. So I put 17 into that v of 1 spot there. So it's going to be 0.5 times 17 plus 12. 0.5 times 17 plus 12. That's going to be 20.5. 20.5. Then if I want my fourth term, I'm going to find v of 3, which is going to be 0.5 times v of 2 plus 12. Now, to find this one, what I'm going to do is I'm going to say, all right, v of 2, well, v of 2 is there, 20.5. So we'll go 0.5 times 20.5 plus 12. And that's going to leave me with 0.5 times 20.5 plus 12. 22.25. 22.25. Perfect. And those are our first 4 terms. And just like that, we are done. But before we finish here, can you tell me, is this last one going to be either a growth or a decay? Well, I'm going 10, 17, 20.5, 22.5. It's clearly growing. So this is going to be an arithmetic, geometric growth. Perfect. All right, so that's how you do it like that. Now that is writing it out by hand, being very explicit with it. We're now just going to take a quick break for a second so I can catch my breath, and I'm going to show you how to do this on the calculator.